Hey, welcome to this not quite DevHub Live. It's a cross collaboration here today with the Near Foundation to talk about a really exciting new event that just happened here on Near, Nightshade 2.0. If you've been following along, or even if you haven't, Nightshade is part of the validation process here, and it introduces now with 2.0 stateless validation. We're super excited for me to have my co-host here, Owen from DevHub, who's one of our DevRels. And our special guest today is Bowen Wang, and he is the head of protocol. Is that how your title? Yep. And he's going to talk all about from, what 2.0, Nightshade 2.0 is, what's different about it. And we're going to get all the different details and how this affects users and everything about the network. It's going to be everything you've ever wanted to know about, Nightshade 2.0 validation, all those type of things. So welcome, Bowen. Thanks for joining us today.
Yes, great to be here and happy to talk about the great milestone that we've just achieved.
Yeah, this is a really exciting time in the Near ecosystem. Can you just give us we'll start with a high level overview of what Nightshade 2.0 is and how that fits into the validation process of Near?
Yeah, so as some of you might know, Nightshade is the original sharding design, and it is basically this full design for a complete sharded blockchain, both in terms of state sharding and also transaction processing sharding. And Nightshade 2.0 is basically, you can think of as an upgrade to the architecture where it introduces stateless validation, and it actually improves upon the original design by making it both much easier to implement, but also give rise to the possibility of much higher performance on each single shard. And there are many other potential benefits like better decentralization because validator running can run lower end hardware, and also more future proof that it kind of positions the protocol to be more ready for eventual ZK adoption down the line.
No, that's awesome. So when we started to think about what Nightshade 2.0 would be, what kicked off the motivation to make this change from the original design to this?
Yeah, so the original design was very elegant, but it had a critical reliance on fraud proofs. So this is just kind of same concept as you have in optimistic rollups. And if there's anything we learned from the world of optimistic rollups is that fraud proofs is really hard, and it's even harder for Near because in optimistic rollup, you're essentially single sharded if you think about it that way. When fraud proof needs to be processed, the consequences that need to happen is still more local or like within a single shard, so to speak. But in a sharded network, that becomes a way more complex. And even in the world of optimistic rollups, still that people are having trouble getting to a permissionless fraud-proof setup. So it's even more difficult there. And while on paper that looks nice, right? The design looks nice. When it actually comes to the implementation, it becomes incredibly difficult, and that's what motivated us to explore alternatives.
Nice, nice. Yeah, one of the things that sometimes people take for granted, obviously, is how this whole network works and, what actually makes something decentralized. Is this actually adding to the decentralization of Near?
Yes. So it basically so before the architecture is that well every single validator on the network would produce chunk for some shard, right? So in order for you to produce chunk for some shard, you must have the state of the shard, right? So meaning that all the validators, no matter how much stake you have and whatnot, you all need to at least have the state of one shard in this design, and that means you need to download the state, store the state locally, and process blocks and chunks with a state. So overall, it's relatively expensive from the storage point of view. And now with the switch to Nightshade 2.0, the validators on the network don't actually need to store any state locally. They validate by downloading the state witness alongside with the chunk, and they can verify the chunk using the state witness without having to maintain any state locally. Now, there is a separate group of people called chunk producers who actually does chunk production for some specific shard, for one shard. and they do need to have the state, but that's a relatively small part of the entire consensus participating nodes. And they can afford to run more expensive hardware because they are the ones with more stake. And then this why this improved decentralization is that it kind of lowers the barrier of entry on the hardware level for the validators out there, and you can potentially have a lot more validators with running not as expensive hardware. Yeah, so basically this help us expand the validator set.
So with this expanding of the validator set, will this likely increase the total number of shards on the network?
It will come down the line, not right now as part of this release. So if you think about the Nightshade 2.0, I often think of it as a new beginning, the beginning of a new chapter, rather than some kind of like end state on its own, right? So what we did is that we essentially transformed the architecture of the entire network, like the entire protocol, to this new design. But we're not actually fully leveraging or like maximizing the potential of this design also in the same release. That is basically for future work. So as part of this release, we're not actually changing the number of shards on the network or like directly improving performance right away, but basically it's just like massive underlying architectural upgrade that really prepare us both for getting more shards down the line and also significantly improve single shard performance. So we have a goal to get to 10 shards by the end of the year, and also dramatically improve the performance of each single shard.
Awesome. We'll hold you to that one. So you've talked a lot about like the benefits of Nightshade 2.0. Are there any drawbacks to this design?
Yeah, so one of the I don't know if you I would say like trade-off, right? Not necessarily put it as like drawback, but one of the trade-off is that because we're now having to transmit state witness across the network, what it means is that the network usage of validators would potentially go up, and I think this is more of a I would say probably a short-term problem. So we're both working on optimizing the size of state witness so that you can reduce the amount of data that needs to be transmitted in order for validators to validate those chunks. But also at the same time, right? If we look at the future from like a future-facing point of view, um, once zero knowledge proof technology becomes mature enough, can be integrated into near, then you can essentially replace the state witness with one zero knowledge proof. Then becomes extremely small, on the order of like a few hundred bytes to a few hundred kilobytes, and also extremely cheap to verify. So I would say it is a trade-off that we're consciously making, but at the same time, I think it is both beneficial for the network right now, and also it would really prepare us for this future where this would no longer be a trade-off. It's just like an advantage.
Mm-hmm. One of the things that comes to mind here is, so there's these different changes here you're talking about of how the validation set is set up. What is changing, if anything, for the developers? As a developer, do we have to be aware of any of this, or is this just going to just naturally improve what we're doing?
Yeah, so I think one of the great benefits that we get from this upgrade is that it's entirely transparent to developers, right? So basically, you as a smart contract developer, you don't have to think about any of this underlying change. For you, like this architectural change from the what we had before to Nightshade 2.0, it's basically yeah, doesn't really affect the developers. I mean, there are some small gas cost changes that may affect certain corner cases, but overall, the developers are not even aware of the underlying upgrade, as if nothing really happened. And I think that is a great achievement on its own, considering the scale of the upgrade.
Mm-hmm.
And I think this is something you've done such a great job at from the get-go, like having like 6 shards I think we're at now, and you don't even have to know like what account your shard is on, what contract you're interacting with. You don't need to think about these shards. You've done such a great job at abstracting this idea of
Yeah. I
shards.
mean, yeah, I would say that's one of the design philosophies behind Near from day one, right? Basically, we wanted to be really easy for developers to develop and deploy smart contract, and as a result, we think it is suboptimal if we have to ask developers to consciously think about, which shard their contract is on and how that affects the usage of that smart contract and so on and so forth. I do also want to point out that I think another great achievement in this process is that any of those upgrades, right, whether it's splitting, whether it's going from four shards to 6 shards, or whether it's the Nightshade 2.0 upgrade, they're all done live, meaning that there's no interruption to the network. And if you think about the scale of this upgrade, right, is essentially where we rewrote a big part of the protocol, and it's almost like an entirely new thing. And then we still did it in a live way, and then there's no interruption to the network, and that's something we really value, right? We don't want it to disrupt the user experience on the network, and I think we've done a good job there.
Absolutely. Yeah, no, that's something that if you've been around for a while now, you see. I mean, the uptime obviously is top tier, but the consideration for that user experience always seems to be in all of the different design from protocol all the way down. I'd love to take a second here and kind of peek behind the curtain a little bit. And can you talk about, we don't have to go too technical for the audience, but you talk about a little bit like what goes into actually making a change like this, and at what point, like, where does this start? How many months back does it take to design and plan this, and the actual implementation that goes into this?
Yeah, so it started about a year ago. I think the ideation or how we conceived the idea would date back to May 2023, right? I think that's where I think we first came up with the idea that, okay, this is something we want to explore, and then from there, I think there were like a couple of months where we just focused on the like specking out the design, what needs to be done, what needs to be changed, and then from there, there's about a full year of implementation work, and then a lot of it is actually spent on testing various things, as you know, with this massive upgrade. There are a lot of risks. So we run a Stake Wars program where we open up this test net for people from the community to join and send a lot of transactions to stress test the network and find potential issues. And that was actually incredibly helpful, as we did find quite a few bugs or like other problems there, and that really helped us shape the foundation for the launch. Yeah, I would say like over the past year and like 3 months, we've done a very good job. I think being able to deliver from ideation to launching on mainnet in that short amount of time. Yeah, I think it's an incredible job. So kudos to the entire team for being able to achieve this.
That's awesome. I remember listening to watching actually your talk at NearCon 23 about this. So I've been excited about it for like a year, and I went back and watched it like 2 more times because I forgot something, and I was like, that's just awesome. And coming back to what this means for developers, that they don't really have to do anything different. I just want to thank you for that as a DevRel, because that makes my job so much easier. But how does this? So we have developers that are building on the protocol, and then we have users who are using those apps that are built on the protocol by the devs. So how can a user expect to see these differences emerge in terms of like gas differences and throughput, like more users using the protocol?
Yeah, so as I said before, in this upgrade, we're basically focusing on changing the underlying architecture, and as a result, we chose to take a more cautious route, just given the kind of the impact of the upgrade, and we don't want to like do too many changes at once. So we're not actually changing the throughput in this upgrade by itself. I think that we just want to see how it goes, whether there are any problems that are exposed. So far, it's going really well. So that's really reassuring. And then right now, we're basically working on leveraging this new architecture and trying to maximize its potential and really improve that single shard performance by reducing the gas costs on the critical path. So mostly the storage or like the state access gas costs, things like state reads and state writes, and that is a very big bottleneck on mainnet today. And I think something like maybe 50% of the gas on some smart contract calls, and or even more is spent on storage or state access. So yeah, that's what we're focusing on right now, and we hope that we can greatly reduce that part of the gas cost and really get the scalability of a single shard to the next level. This is largely thanks to the architectural change we did so that we can put state access entirely in memory. And this, yeah, as you said before, it's a great benefit that we get from the new stateless validation architecture.
Yeah, no, that sounds really great. When you are upgrading the validators, I saw. So I host a validator, and I saw a new term, endorsements. Can you talk a little bit like what endorsements are and how that fits into the stateless validation?
Yeah, so basically, because now we are like this upgrade basically makes the network fully sharded. No single validator needs to track all the shards. And when the chunk is produced, basically because of the stateless validation, on every block, validators get rotated to different shard. And this endorsement basically to say like, okay, I validated that this chunk is actually valid according to the state witness I received, and therefore I send this endorsement to the block producer so that they can include it in the block they produce, so that everyone else can verify, okay, this chunk that was produced indeed have sufficient endorsement saying that it is valid. So yeah, this is basically an important part of what makes the stateless validation work. Yeah, that's it.
Neat.
And with this update, so we've spoke a lot about stateless validation. Can you talk about any other changes? Are there any other changes than just stateless validation happening here?
Yeah, so in this release, it's actually more than just stateless validation. We also packaged the congestion control change into the network, because those two actually have some intersection when there are missing chunks on the network. So basically, the idea is that today, there, sometimes or rather before this release, what will happen if a shard becomes congested is that you send a transaction, you may wait for like a pretty long time for it to be processed, and on the client side or on the user facing side, like on the application side, you might see a timeout error, which is pretty annoying. You don't actually know what happened. It could be that your transaction gets lost. It could be that your transaction get in, but they're just waiting to be executed. And what we found is that people did not like that, and they found it to be very, very annoying, and also just like not great for the protocol itself, because it creates this pressure on the shards, and then it may actually cause some unbounded memory growth and so on. So we kind of fixed that, and now the fix is actually quite complex, so I won't go into all the details here because of sharded design. But basically now there's this back pressure that goes through the shards, so that if a shard is congested, or there's some congested shards on the network, as a user, what you might see is that your transaction gets preemptively rejected when it is submitted, because it will basically say that the shard is congested. Please try later. This I mean, from at least from my point of view, it's a like better experience, because at least you know when you submit a transaction that it got rejected, so that you can, let's say, resubmit later, rather than waiting indefinitely, not knowing what actually happened, and maybe trying to guess, and maybe even making mistakes by sending another transaction that does the same thing twice, which sometimes isn't what you want to do if you're doing transfers and so on. And I mean, obviously, this is not the full solution, because it's still like you sometimes I mean, for some application maybe you're fine, like, okay, the network's congested, let me just wait for a bit. But sometimes you're doing like trading, or I don't know, moving large amount of assets or not, that you really want it to be done right now. So that's the next stage of the work, where we would introduce transaction priority, so that you can say, okay, I'm willing to pay more to kind of cut the line and get to the front of the queue. So that would allow your transaction to be processed faster, even if there is congestion on some shard.
What it sounds like is, what you're saying going through here, is it fair to say that these are part of phases? So Nightshade 2.0 is not the end state by any means. This is leading to a lot of other features. I know I've seen in different talks and in documentation the concept of dynamic sharding. Is this all like a preface to how we eventually get to that point?
Yeah, for sure. And I think the stateless validation architecture actually makes it easier to implement dynamic resharding, because now the validators themselves are actually stateless, because you're stateless, then you don't like technically care how many shards there are. So if there is a split of shard and the change of layout of a shard, you don't really need to do anything per se, because you are not even keeping track of any shard. I mean, of course, there are work on the chunk producer side that needs to be done, but overall, this, because the validation part, basically how the network tells whether a chunk is valid, this part is basically entirely stateless. It basically makes the design and implementation easier for dynamic resharding. And actually, we have already started discussing the design of how we can potentially get there. I think it's not something that can be done in one day. And I think there are going to be a series of steps that we need to take to gradually get there. For example, first we implement how you can split one shard into two shards very quickly, and then like maybe also like how two shards can merge back into one shard. And once we have all those things, we'll figure out what is the criteria for the system to dynamically determine that well, now it's the time to actually split one shard into two, or now is the time to actually merge two shards back into one. So yeah, I think there are a few steps that we need to take to get there. But with the new architecture, we're confident that it will be done.
Maybe this is too much of a specific question right now, but I'd be interested in hearing, when you're saying the splitting of shards and the merging of shards, what sort of timeline does this happen over? So, say shard 3 is congested, there's so many transactions happening to this one application, say Sweat or Kaiching or whatever. When can we expect the shard to split to help handle that?
That's a great question. So when I said there are a series of steps, I think one thing that I was glossing over is basically this question of like how fast could it be done. So the end goal is to do it basically within a few blocks. So essentially to react in real time, and I think it is possible to do. It does make the implementation more complex, because currently the shard layout is determined by epoch, and one epoch is about like 12 to 16 hours. So right now we're kind of building towards that, but first step is, well, let's split the shard within like one epoch, and then we can go from there to actually splitting the shard within like a few blocks. I think we do have a pretty good understanding of what needs to be done to get there. Yeah, I think we're pretty confident that it could be done. I think it's just a matter of implementation and actually putting in the work.
That would be crazy, to be honest. I was thinking on the time scale of like epochs and hours, but a few blocks, that would be amazing. What do you think, Joe?
Yeah, I mean, yeah, I can't even. My brain doesn't process that. That's crazy. With all of this, and I think with this is a really amazing technology, and where I feel that Near Protocol has continued to kind of push the boundaries of some of this stuff. The instant thought is like, oh, everything has to get bigger and more powerful, but really, the standards for a validator, especially for a stateless validator, have gone down. Is that correct?
Yes, that is correct.
Yeah. So how is that all work? How are you able to continue to lower the requirements, yet essentially add more features and make it more performant?
Yeah, that's a great question. I mean, I think I mean, this may sound counterintuitive, but if we push it to the limit, right? If we think about the extreme, is basically let's say you have like a powerful machine that generates zero knowledge proof, and then you can have a lot of very, very cheap machines that verify the proof, right? Then the verification is almost instantaneous, like a few like tens of milliseconds on that order of scale, and then the compute requires also pretty low to do the verification. So basically, it is possible that you can pretty much mimic what a centralized system does today. Is like you have this powerful machine that does some compute, but in centralized system you don't verify it, so to speak. But then like this like ZK is like a technology that really allows you to get very close to that. You have like some powerful machine that does some like compute, and then you generate this proof that can be really, really cheaply verified by a lot of other very, very cheap machines. Right? We're definitely not there yet, but
Right.
if you think from the principle, then yes, you can actually do it. You can have some kind of expensive machine that does some compute, and then like there are other people with much less expensive machines that actually do the verification. And this asymmetry is actually pretty core to the design, and I think it's actually a nice way to kind of get closer or like improve the performance of the system dramatically, because now instead of everyone have like the same amount of hardware, and it getting bottlenecked on that kind of hardware, which is pretty limiting. You now are basically having this like more powerful machines that you can like kind of like leverage while maintaining the decentralization of the network, because the verification is done very cheaply.
Mm.
Using ZK proofs in this manner, I imagine, would it take longer to like verify blocks? Because I know that ZK proofs can take a while to generate. Is that why you're taking your time and not just implementing proofs right now?
Yeah,
I'd be interested to hear more.
that's pretty much it. Yeah, I think right now basically the proof generation latency is too high to be practical. But I mean, like we have seen in the past couple of years, there has been great progress in both the theoretical part of ZK, the advent of new proving systems that really improve the efficiency of proof generation. And also on the engineering side, much better implementation of those proving systems that makes proof generation faster, and so on and so forth. I think the next big thing that will probably come is the hardware acceleration that would really allow us to get closer or much closer to real-time proof generation for execution. And then if we can get close to real-time proof generation, then yeah, we can start thinking about integrating it into the protocol and really reap the benefits there.
Mm-hmm.
Yeah, I feel like ZK is just so awesome, and I'm waiting for the tech to catch up with. Well, the theory is also catching up, but I just imagine the possibilities it's going to unlock when you have like real time proof generation. That would just be amazing, I suppose.
Yeah, that'll be great.
Oh, sorry to cut you off there. I just want to jump into some of the security pieces of it. I think, obviously it's on blockchain, that's a huge piece of everything that we're doing. And one of the questions that comes to mind is, so one of the things around security has always comes up of, not necessarily just on Near, but on all chains, of how much token is distributed across the validators. And so what percentage is like that top group that holds most of the tokens. And now what we're starting to see here on Near, because we're expanding the validator set as well, how does that affect where, how much token is held? Does that matter as much still? Or how does that all fit into the security design? What's happening?
I think it still does matter in a sense. So I think the argument or like the concern that people have with the concentration of stake is that those few people can actually collectively, if they decide to collude, somehow they can halt the network, right? So that is still the case. The crypto economics side of things does not change. I mean, if let's say 1/3 of the stake decide to collude, that yes, they can stop the network from running. But I mean, I think what this release helps is in the sense of actually getting to more validators and allow more people to join. Yeah, I think just from a kind of a social consensus point of view, that definitely makes things much harder to manipulate and so on. So yeah, I think that is definitely a benefit of this release.
Along those lines, with stateless validation, is there, can you tell me, like, I guess I don't even make assessment judgments here, but like, how does the security then work for that, where you have these witnesses that are there? Is there opportunities where they could possibly collude and still validate as like colluding witnesses, or is that something that's just not possible?
I mean, I think it is possible in the sense that if more than 2/3 of the stake decide to collude, then I mean all bets are off, right? So that
You have
basically
bigger problems then, anyways.
the fundamental BFT consensus assumption is broken. Then yes, things will go very wrong. But I think from the crypto economic point of view, like assuming the BFT assumption holds, then yeah, the probability, because the validator shuffled every block, the probability of a shard getting corrupted is basically negligibly small, and that's where the security assumption is from.
Yeah. Yeah, no, that's great. I mean, I assume that's kind of where it was going, and I just think it's important that as people are hearing these discussions online, they understand what really is going to the security and the level of actual, one, collusion that would have to happen for something to actually really go wrong, and then two, that, like you said, which I find really fascinating here, is that, as we're able to put in, again, more validators with less hardware requirements, we are actually, making this a more secure system because we are decentralizing it, and as through the rotation and things like that, correct, that make it better. So awesome.
Yeah, exactly. Yeah.
If you don't mind me switching gears here a bit, I've been looking on GitHub, looking at the NEPs, and I've seen a lot about Ethereum alignment and Ethereum implicit accounts. Is that to do with Nightshade 2.0, or is that something different?
Yeah, that is different. It basically is implementation that would potentially allow MetaMask to support Near natively. So basically allow Ethereum accounts to be supported natively, so to speak, on Near. And I think that is completely different. Completely separate from the Nightshade 2.0 release. But it's also, I think, a great feature to have, so that that potentially allows a lot more people in the Web3 space to start using Near directly. I mean, that's only part of the chain, right? There's also the Ethereum RPC implementation that's being done, and the MetaMask integration, so that basically you can go to any Near app and then just start using MetaMask to interact with it as an Ethereum user. And yeah, I think that has the potential of bringing a lot more crypto native users to Near.
It really plays into that chain abstraction narrative that Near is becoming all about. Which is interesting.
Yeah, no, I mean, it's a lot of really great stuff here, in the phasing of all this. Is seems really well thought out, and you guys are clearly building towards something. Can you talk a little bit about just the you don't have to get into deep detail, of like where you see the next few phases kind of going in the direction from here?
Yeah. So I think the one of the big focus for us is to maximizing the potential of the current design. I think, as I said, it's the beginning of a new chapter, and we are essentially only getting started with this new architecture, and we really want to maximize both the horizontal scalability and also the vertical scalability in terms of getting to both more shards and significantly improve the single shard performance on each shard. So I think this is a big focus for us going forward. Now, looking beyond that, I think the next thing that comes is the dynamic resharding that I've already talked about. Basically, then you have this basically the holy grail of sharding, where the number of shards dynamically adjust based on the load on the network, right? So that is something that will be really great to have, and basically then we don't need to worry about the scalability side of things and so on. And obviously we could talk about ZK and its potential application in the protocol, and I think that is also something we have in mind. But I think that may take a longer period of time to get implemented, just depending on the progress on the ZK side.
As a as you are planning this out, and as you're trying to bring validators up to speed and keep everything else like that, where how does that fit into, I guess, like release schedules as well too? Because it's not obviously where you guys can just build and feel comfortable say, oh, we're going to deploy this. You have to get validators on board. Maybe for those who don't know and don't understand how all that stuff works, quickly just talk about like what a release actually looks like and what is actually contingent on being part of the protocol.
Yeah, so I mean, all the releases are, including this one, pretty similar in how they get adopted. So basically, the release gets published on GitHub, and it contains a protocol change. And then as validator adopt the release, they basically vote for the adoption of the release. And when there are sufficient number of validators adopting the new release, so the threshold is set to 80%, then the network will actually switch to the new protocol version in 2 epochs. And this is basically to make sure there is this voting process going on with every single release. And as a result, people also get get to have the time to actually adopt the release and so on. So I think it's the same process that we've been using for a couple of years. Yeah, I think it's going well for us.
Have you ever had a time where it didn't go through, like it did, like something like it didn't get voted through?
I think we've had time where it took longer than what we expected. So basically, like there's a voting date or voting time that is set in the release. What that means is that after that specific date, then the voting would proceed, and then the network will basically count the votes and decide whether to do the upgrade or not. And but it doesn't prevent people from not upgrading and thereby stopping the network from being upgraded. I don't think people intentionally did that in the past, but there are definitely times where the upgrade took 3 weeks to get adopted by enough validators because
Sure.
this is a decentralized process.
Yeah, and correct me if I'm wrong here, but right, a vote simply is the validator updates to that protocol version, and that counts as a single vote.
Yes,
Okay.
yes. Yeah.
Nice.
How long did it take people to uptake Nightshade? Was it 3 weeks, or were people upgrading within within an hour of the release?
It's actually nicer. And also it's faster than I expected. I expected just because of the complexity of the release, and it actually does require some manual change on the validator side with regards to the config file. So it is more complex than before. Yeah, enough validators adopted the release in 1 week. So basically, it took about a bit more than a week from the public from the when the release gets published to when the network got upgraded.
Yeah, no, that's exciting, and I've noticed too for myself, just again running that validator, that over time, especially I would say all the releases this calendar year have been a lot smoother, and it's just been a process where I don't have to think too much about it. Yeah, it's true. I have to maybe make a small change in the config, but you seem to have streamlined it. Is that more of a process thing, or is that simply just as you are getting better at improving the protocol and over time?
Yeah, I think it's probably both. I think the processing is basically right. You kind of learn from the mistakes and in the past, and you work on improving it and making it easier for people to upgrade and so on. And also, yeah, we're definitely making um, a dedicated effort to improve the release testing. And I think, yeah, we've done a pretty good job, yeah, in the past couple of releases, especially with this Nightshade 2.0 release, to really have very extensive testing before the release goes out, so that this would minimize the number of issues that the release may have, but also make it easy for validators to upgrade, because we also can see the problems, that potential problem that each individual validators may run into when they do the upgrade.
Yeah, no, that makes a ton of sense, and we've definitely seen the outcome of that, because I would say, again, just the past 6 months, some of the updates between, the sharding changes and everything else, like you said, there's been no downtime due to it, and it's just been a fairly seamless process as best as it can be at this point. So that's exciting. I just want to wrap personally, and I don't know if you have a final question too, but with all of this stuff, we talked about phasing. We talked about where this is going and the importance of all of this. Near has a few different initiatives, and we don't have to. I don't want to dive into the actual different initiatives here, but the blockchain itself is just the protocol that anything can kind of be built on top of it. Is that the goal here? Where yes, you are optimizing for some things, but it's really about building flexibility into the chain, or there eventually become a path during this phasing where there is a more of a focus towards a direction like some other chains do.
Yeah. So sorry, what's the last part?
Sure. Well, so some chains are like more focused on particular features of the protocol, and so they kind of like hyper optimize for those things. But is it fair to say that like Near is really focused on not hyper optimizing for everything, because you can't, but for everything, but really focusing on being a protocol that you can build almost anything on, whether the initiative is chain abstraction, whether it is AI, whatever it might be, it's more generic.
Yeah, because kind of going back to our roots or our original vision, right? It's a world where people have control of their money, assets, power of governance, and it is something that requires a planetary scale that to support this kind of whatever apps that people build and so on. So we want it to be both highly scalable, but also at the time general purpose enough, so that any kind of application, any kind of use cases could be built, and to really kind of collectively help with the mass adoption of Web3.
Nice. Any last questions?
No last questions, except I would just like to say, like, a huge congrats to you and the team for getting all this implemented. Like, huge props. So glad to see it happen. And yeah, thank you for making our lives easier.
Thank you. I mean, it's a great work from the team. So yeah, would like to give a shout out to them.
Yeah, yeah. I want to end here of saying, like, I think, I hope people who are following along, especially those who are technical, understand the work that you and your team are doing. This has been something that really has been impressive, and probably doesn't get as much fanfare and excitement because it's in the background, and I think one of those things where, like, it just works, right? You don't have those news stories of it having problems and things like that, and that's a good thing. And I wanted to really make sure that we continue to highlight these changes because Near's protocol is really state of the art, and it's really impressive of what you guys continue to do, and we're looking forward to all the future changes. So we really appreciate your time coming on today. We know you're super busy, but this was really informative, I think, for both ourselves as well as the audience. Thank you.
Yeah, thank you.